Hi everyone, so today we're going to look at how to find the local truncation header for the heat equation using the 4-point explicit scheme. Okay, LTE for 4-point scheme. Explicit scheme for the heat equation UT equals to UXX. Okay, so the 4-point scheme is given by n plus 1 equals to RUM minus 1n plus 1 minus 2RUMN plus RUM plus 1n. Now the local truncation error is given by TMN plus 1 equals to UMN plus 1 minus UMN plus 1. Now this is the approximation, which is pretty much this one, and this is the exact. Okay, let's find the exact first. The exact is given by the small u here. We can write this in the form of xm Tn plus k. Now expand this in terms of series will give you 1 plus k partial over partial t plus k2 over 2 factorial partial squared over partial t squared plus in another word umn, or in another word I can write this as multiply u inside u plus kut plus k2 over 2 factorial utt left with mn. Okay, this is the exact solution. Now the approximate solution, which is my 4-point explicit scheme. Okay, my 4-point explicit scheme given by BQMN plus 1. Okay, I'm just going to write it down the equation, and then you will see what I am going to do now. Okay, this is the approximation. Now we need to expand all this term in terms of Taylor series. So let's expand m minus 1n, which we have u xm minus h tn. Okay, writing expanding in terms of h now, I have u minus h ux plus h2 over 2 factorial uxx minus h3 over 3 factorial uxxx plus h4 over 4 factorial uxxxx, whatever the other term, mn. Okay, and next is to expand um plus 1n. So we have similarly um plus 1n, which is uxm plus h tn. Now same as this, but with a positive sign. So u plus hux plus h2 over 2 factorial uxx plus h3 over 3 factorial uxxx plus h4 over 4 factorial uxxxx, and so on. Now putting into the approximate solution, which is this equation here, put a star here, you have umn plus 1 given by r multiplied by this term u minus hux plus h2 over 2 factorial uxx minus h3 over 3 factorial 6 plus h4 4 factorial is 24. Okay, plus 1 minus 2r This is remain the same, plus r. What is m plus 1n? Is this equation here, the Taylor series expansion for this one. So I have u plus hux plus h2 over 2 uxx plus h3 over 6 uxxx plus h4 over 24 for factorial. Okay, so what happened now here? We can cancel out some term. This is rumn, which is give me 2r. So this term cancels out. The next term we have is negative, positive. So this and this cancels out. This will leave us with r h2 over 2, r times h2, uxx plus r h4 over 24 uxxx x. Okay, and then I have 1 of um. Okay, we'll leave that later on, and then this and this plus r h2 over 2 uxx plus r h4 over 24 uxxx mn plus umn. Okay, so this is what you have for the approximate solution. Now I can simplify this. Okay, simplify this. This will give me umn plus 1 equals to umn. But what is r and r h over 2? Will give me rh squared. rh2 uxx plus this plus with this, we have rh4 over 12 uxxxx mn. Okay, now putting back into the LTE. Okay, LTE, which is given by tmn plus 1 equals to the exact solution minus with the approximate solution. So earlier on, this red color which we have obtained by the exact solution, we have expand in terms of t, which is this one, u plus kut plus k202 factorial utt. So I have u plus kut plus k2 over 2 factorial utt minus with this whole term here, umn minus rh squared, okay, minus uxx, I'm just gonna continue from here, plus rh4 over 12 uxxxx bracket mn. Okay, we are almost to the solution now. Now simplifying, let me use the blue color now. So obviously here I have m and n. Okay, so this term and this term cancels out. I have with kut plus k2 over 2 factorial utt minus rh squared uxx minus rh4 over 12 uxxx x, this whole thing mn. Now what we can see here, we know that ut equals to uxx, so I can, this is k. Okay, this is k because k r equals to k over h squared, so k equals to r h squared. So ut equals to uxx, which is, this term is 0. Left with k2 over 2 factorial utt minus rh4 over 12 uxxx. Okay, so we are almost into the solution for finding the LTE. So where my LTE, simplifying this. So since k equals to rh squared, so we can write k. So I can write this k2 over 2 utt minus rh2 h2 over 12 uxxxx, where this is my k. Rh squared is my k, so I have k2 over 2 utt minus kh2 over 12 uxxxx. If I have to factor out my k squared over 2, so I have utt minus I need h squared over r. Okay, k equals to, okay, taking out another k, I need to have another k here, which is, I can write this way, r equals to k over h2. Okay, r equals to k over h2, so I can write this as 1 over 6, 6 times 2 is 12, r uxxxx. There you go. So this is called the principal part. Principal part of the LTE. So the local order accuracy is given by k2 plus kh squared. K2, forget about the plus minus sign, kh squared. Okay, so this is how you find the LTE for the explicit 4-point scheme. That's all for today.